very familiar with how our number system works by this point, right? So how many numbers are in our number system? How many numbers do we have to work with?
A lot.
Infinite?
Josie had her hand up nicely and didn't just blurt it out.
Infinite.
Infinite, okay, that is a correct answer. So that is, we can represent an infinite amount of numbers, right, with our system. But how many individual little digits is what we call them? And there's a reason we call them digits, right?
Well, isn't it 9?
No.
Because after 9 it just becomes 1 0.
Well, what is 0?
It's a digit.
Writer?
There's 10 real numbers.
There's 10, right?
Real numbers.
So, the way that we represent our numbers is we have 0. I was not in CC, so if my handwriting isn't great, that is why. So be thankful, okay? 2, 3, 4, and it goes on all the way up till 9, right? So we have 10 ways of expressing numbers. We have 10 symbols that we can use. And do you know why we call it digits?
Because
Alistair?
there's numbers, they're like numerals, the digits that we use to form all of
What we call our fingers.
fingers.
Digits. Why do you think we have 10 numbers that we use typically?
They go into 10 fingers.
It's the easiest thing to count with, right? We have 10 fingers. That's the easiest way we have to count. So we've got 10 digits that we can use. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when we get to 10, what happens? Do we have a whole new set of symbols?
No.
No, we don't. We represent it as this, right? Okay? So this is like basic math overview, okay? And I know that this is a little bit boring, but it's going to help you when we talk about basics. So, in the number 10, what do we have going on here? What space is this? Anybody know this one? Alright. No? This one right here.
Oh, that's the one.
This is the ones. This says I have 0 ones. Right? When we get to 10, I have 0 ones here. And what's this space? The tens. Okay? What if I did this? What is this column here? That's hundreds, right? So what this is representing is I have 0 ones, I have 1 10, and I have 1 100. So this plus this plus this. Right? That's what that represents. Numbers, when we see them, is just representing a value of something, right? So when we see 110, that means 110 somethings, right? And you probably all had math problems you get wrong because you didn't label what the something was. I said 110 and I was right, but I didn't say 110 grams, right? That's because numbers are representing things. So you have your spaces here. So when we talk about bases, what we're saying is, in base 10, which is what we're all used to, our number system, we have 10 symbols, 10 digits that we can represent numbers with, right? That's base 10. We have a set of numbers. I've seen this in your books, so I know you're familiar with this, right? You have a set of numbers, and it keeps going. That's what that will represent. That go from 0, 1, 2, 3, and on. This is base 10, right? Does that make sense?
Yes.
Yes.
All right, questions? Yeah. Everybody's good? Okay. Got 10 symbols. Yes, Ryder?
So for the for the ones place, you just have to be the number that it is. But for the tens place, since it's base 10, you take that number and times it by 10.
Right. So when you're talking about places, if you had, let's practice base 10. Okay, let's do some base 10 practice. If you have this number, okay, what number is that? Oh, good job! That was great! Everybody got that one. I'm so proud. I'm so proud. Ransom came So, we have this space. This is what space? The one space. So how many ones do we have?
3.
Right? That's 3 times 1. Right? So we have 3. Okay? This is what space?
The 10.
The tens. So what does this represent then?
10.
20.
Right? It's 20 because why?
Because
We have 2 tens, so 2 times 10 is 20. So we have 20 plus 3, and we represent it by saying, okay, we have 2 tens, 3 ones, we have 23 of something, right? So that's practice. We're going to do another one here. Just for fun, practice. I know this sounds, it's so boring, right? It's just like, ugh, such boring numbers. Okay, we'll do this. Okay, what is this? 1,123, right? Because this is what space? Ones, and how many ones do we have?
3.
We've got 3. This is what space? Tens. We have how many tens? Right? Which means what?
Yeah.
20, right? So we got 23 there. And then we have, what space is this? Hundreds. So we have 1 100, 2 tens, 3 ones. What space is this? Thousands. So this is 1,000 plus 100 plus 20 plus 3 is what this represents, right? That's all in base 10. Okay, but we can have other bases. The question is, what happens if we have a number system, right? We have a set of numbers that is only has 2 symbols available to express things. What do you think those would be?
20.
Josie, you would 0, right? We always start with 0 to represent nothing, right? And then we have 1 to represent something. This is base 2, which is also called binary. Okay? So, if we want to represent, most of the time base 2 has at least, it shows both numbers, so it's easier to see what's going on. Okay, so let's just do this. Okay, if we wanted to represent 0, how do you think we ought to write it?
0.
Somebody who did blurt it out without raising their hand. I waited to call out. Eileen, what is that? 0, right? Okay, a lot of times just to make sure we don't get confused, we'll go ahead and say, yeah, there's a 0 in this place too. It's just 0, 0. That represents 0. Okay, so this is not different, right? Just don't pay attention to this in this place. This is not different. 0 is exactly the same, correct? Okay. What if we wanted to represent the number 1? We have 1 of something, but we only have 2 symbols to explain what that is. Ryder had his hand up. He was eager. All right?
In the ones place, you just put the 1.
In the ones place, we put a 1. Right? And so then we would also have 0 here, just saying there's nothing over there. Okay? Now is where it gets tricky. We need to represent the number 3, but we only have 2 symbols. I want to see if I can get anybody who hasn't answered yet. Ollie?
Just put 3 1s.
3 ones. Why would you do 3 ones?
You can't put 3.
You can't put 3. This is where it gets tough, right? So in base 10, we have the ones place and we have the tens place. Okay? But in base 2, we have our ones, right? That's just ones, but our set rolls back over at 1, right? We go 0, 1, and then what the next number is not 2, it's not 3,
0.
right? The next number would be 0. So what we have to do, just like in base 10, when we get to 9, we don't go some other number representing what 10's value is. We say, nope, I have 0 ones now, and I have 1 in the next set of numbers, right? And so in base 2, when we have 3, we don't have the number 3 to represent it. So what we have to do, is where it gets tricky, is we have to roll it over. And when we roll over into the next column, we put a 0 here because we have 0 ones, but in our next column, we have a 1, right? Representing that we have 1 of the thing that goes in this column, and we have 0 of the thing that goes in this column. But our number set is smaller than our 10 numbers before. So, when we do this, what we're actually saying is, okay, this has nothing here, but when I get to here, what this represents is like 3 tick marks. Okay?
It'd be 2,
Yeah.
right?
2. Yeah, I apologize. I should have said 2. It was 0, 1, and then 2 comes after 1, not 3.
Yeah.
We'll just, or represent that.
Maybe you should work on your base 10.
Cut that one out of the thing, right? I made the same mistake at home. But yeah, so our number set, right? If we are looking at in normal base 10, we have 1, 2, 3, 4, 5. We'll just stop there. We'll go 0, 1, 2, 3, 4, 5. If we wanted to write 0 in base 2, what we're going to do, we're going to say 0, right? Because we have that symbol available to us. Here, I'll put these like that, so you see it's different numbers. If we want to represent 1, what we need to do we have a number that can represent 1? Do we have a symbol, right? So that's going to be a 1, right? If we want to do 2, do we have a 2 symbol? No. Teddy? It's going to be 1, 0, because we have to then put that amount of things in the next column. Say, okay, we've got one of those, and then we have 0, 1s. If we go down to 3, what's that going to be? Josie?
I think it would be
1, 0, 0? No, not quite.
101.
It would be 1, 1.
1, 1. That's correct.
Because
Right?
the base system, instead of going ones place, tens place, hundreds place, it's one place, two's place, 4 place, 8 place.
Correct. Did you hear what Ryder said?
Yes. I was
In the base system, we have, or in the base 2 system, we have a 1's place. The next column is 2's. It says, how many 2's do I have? Okay, the next one is, well, how many 4's do I have? Okay, so each of those, instead of multiplying by 10, it's multiplying by 2 or 4. It just keeps going up, right? So this one, let's apply that here now that Ryder's said that. Thank you, Ryder. If we wanted to do 4, what would that be? Let's try counting up. How many 1's do we have in 4?
4.
Well, we've got 4, but we don't have a way to represent that, right? So we have to put a 0 there. What about 2's? How many 2's do we have?
2, but you can't.
We have 2, but we only have 0 and 1 to represent things. So what should we do there?
0.
We'll put a 0. Okay. Now we say, okay, in the 4's place, how many 4's do we have?
1.
We have 1 4, right? So 4 in base 2 looks like 100 to us, right? But what we're actually saying is there's 0 1's, there's 0 2's, and there's 1 4. Right? Because that's the amount of symbols we have. I can see like some brains just going, just like coming out the ears right now. I totally understand. What we're gonna do next, we're gonna try a different base system for you to start we're gonna try making some numbers in a different base system too. Okay? Who said 5? Get out of my head. Alright, we'll try base 5. Because 5 is a nice number that we like. Okay, so we're going to do base 5 this time. How many symbols will we have in base 5 available to us?
5.
5
6.
symbols, right?
5.
The 5 represents how many symbols we have available to represent numbers, right? So we'd have 0, 1, 2, 3, and 4, right? But when we get back to 5, that's a new column. It's a new place. Rather than 10s, we're saying it's 5's places rather than 10s. Yes, Ryder?
Did you know that before the basic 10 system was the common system, multiple peoples use the base 60 system because it was so divisible.
Interesting.
That's
Very
also
cool.
why we
There's
use
also good arguments for base
64.
12, but we will focus on trying to understand these here for right now. So, if we want to represent 0 in base 5, we've got 5 symbols to represent 0. What do we do? 0, right? We want to do 1. We have 1, 2. Well, we have a 2 now, so we can represent that with a 2, right?
Yeah.
And we can keep going, and I'm just going to do this for time's sake and for writing's sake. We can go all the way up to 4, and we can say, great, I've got symbols to go all the way from 0 to 4. That's 5 symbols, because I'm in base 5. Okay, but what if I want to represent 5? Who wants to take a crack at it? What goes there? Let's see. Somebody new try. Somebody who hasn't spoken. It's okay to make mistakes. Yes.
We put a 1 there.
A 1. Why would we do a 1?
There's 1 5.
There's 1 5, right? But so that settles our 5's column, right? That settles our 5's place. But what would go in the 1's? 0, right? Because we have 5 plus 0 equals 5, right? 5 of something plus 0 of something equals 5. And that's what we're representing, right? Because this is 0 something plus 0 something, this is 0 something plus 1, right? Whenever we're writing a number, we could write, even in our number system, base 10, we could write this. And it looks really funny to us, but we could go infinitely far this way because we're saying we have nothing above this. We have 1 plus nothing in any of the other columns, right? And what we're doing in these base systems is we're saying each of these columns, rather than representing 10 of something, they represent whatever the base is. So this is base 5, right? So when we get back to a 1 of something, then we're representing a 5. So that was exactly right. Okay? Let's try another number in a base 5. We'll make it tricky for fun. Because I know everybody, when they're struggling to understand a concept, wants a tricky problem, right? Let's do, we won't make it too tricky. We'll do 9. We'll try 9 first. Okay, so for 9, yes, Josie?
1 4.
1 4. Why would it be 1 4?
There's 5. 5. Well, there's 1 5 and then 4 1.
Okay. This is the 1's column. This is a 5's column, right? So what we're actually saying when we write 1 4 and we're in base 5 is that we have 5, it's weird writing sideways, I apologize, plus 4. That make sense? This means 1 5, this means 4 1's, 5 plus 4 equals what? You guys got this one. This is an easy one. What is it? It's 9, right? So what we're saying is, it's just a different way of representing the same amount of something. Okay? I'll try and tie this together with a really, really light. Hey, we learned this back when we were little kids and we were just learning how to count, right? Okay, 1 we can represent this way. Okay, 2 we can represent this way. Right? We're just talking tick marks. We're just putting in a different kind of something, right? If we want to do 3, what do we need to do?
3 1.
Big orange.
No, these aren't 1s. They look kind of like 1s. Here, let's make it even more distinct.
So tally. But
There we go. Okay? These just represent something, right? We're going to do 4. Right? How many are we going to do? It's going to be like that. This is the same way of saying that. We're just using a different set of symbols, right? If I want to do let's see. 12, using this system to represent it. What should I do? Well, I need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? This is the same thing as saying this. But this is in base 10, and this is in X's. Right? So when we're talking about bases, when we talk about base 5, we're doing exactly the same thing. We're saying, hey, when we get to 5, we need to put a 1 over here in the 5 column, because that next thing is a 5 column rather than a 10 column like we're used to. And so it's just about putting all those numbers together and doing the math. I don't expect it to like make tons of sense right away, but the more that you work with it, the easier it gets. You do more of those problems and it'll start to click just like all the other math problems. Yes, right? You have a question?